1/6, but I already know the lesson 6 stuff.
Okay.
So I don't quite understand the chapter 7 though.
Oh, chapter 7. Okay, this chapter is hard. Okay. Now I can explain. So can you tell me what is the question? Do you have any question? If you don't have any,
on the lesson 5, I have a question on 5.46.
5.7. So that's in the chapter 5.
Yeah.
Okay. Now let's go chapter 5. So your problem is 555?
Problem 46.
5.46. Okay. 5 point. Okay, now let's see. $5.46. Okay. So can you read this problem?
In triangle ABC below, AC equals 4, BC equals 3, AB equals 5, and angle ACB equals 90 degrees. The infinite sequence of points C1, C2, C3, C4 is generated as follows. C1 is the fluid of altitude from C to side of line segment AB. Line AB. C2 is the foot of altitude from C1 to the side line AC. C3 is the foot of altitude from C2 and to side line AB, and so on. Calculate the sum CC1 plus C1, C2 plus C2, C3, blah, blah, blah.
Okay. So then they ask you to find the sum of this segment. So then, now let's do it. First, can you find not C1? Say, they tell you AC equals 4, right? BC equals 3, and AB equals 5. So now you know we already learned C1, this one square equals AC1 times BC1. Do you know this? So this side square equals AC1 times BC1. Do you know this?
I don't think so.
You don't think so? You know, I told you if we have a triangle, if we have a right triangle, suppose this one is a right triangle, okay? Then if you draw the vertical line here, now let's see, suppose here, this one is A, B, C. This angle C is 90 degrees. This one is 90 degree. Then this one is 90 degree. This D. Now, you know, in this here, remember I told you in this one, this is a very important diagram you need to memorize. In this paragraph, in this diagram, we have three pair of the triangle are similar. First one, we have triangle ACD. ACD similar with triangle BCD. This one is similar with this one. Do you know why? Triangle ACD similar with BCD. Because say this one, we have this angle equals this angle. This angle equals this one. And also third angle, that's right angle. You know why? Because say, suppose this angle is x, this angle is y. So x plus y equals 90 degrees. Then this angle will be x because x plus y also equals this 90 degrees. So that means this angle equals x, this angle equals y, right? So then in this two triangle, we have corresponding angles, two pair of corresponding angles are congruent. Therefore, these two triangles are similar. Then we can get CD over AD will equals DB BD over CD. You know, you can use CD over AD will equals BD over CD. Then you do cross multiplication. You get a CD square equals AD times BD. Okay? So if you say in this paragraph, we also can get a similar expression. AC square equals AC times AC1 times BC1. Now, do you understand? Okay, if you understand this, now we can continue. Say, you can also get, say, got a BC, you can get a BC square equals this one, BC square equals BC1 times AB. That means in this triangle, you have BC square equals BD times AB. You also have AC square equals AD times AB. Now, from this, you can get BC1 equals what? You know, because you know BC, that's 3. So that's 3 square equals BC1 times AB. AB equals 5. So from this, we can get BC1 equals 9 over 5. So BC1 equals 9 over 5. Then AC1 will equals 5 minus 9 over 5. That will equals 5 minus 9 over 5. This gives you AC1. So AC1 will equals 25 minus 16 over 5. So AC1 equals 16 over 5. Then that means AC1 will equals 9 over 5 times 16 over 5. Then CC1, that will be square root of this one. That will give you 3 times 4, that's 12. 12 over 5. So you got a CC1 equals 12 over 5. Then you calculate C2, C3, or C1, C3, C1, C2. Okay, what is the C1, C2? You need to calculate C1, C2. C1, C2 equals C2 times AC2. Okay, so now let's calculate this. C1, actually you can also have either way. This one, because it's in the triangle ABC and AC1, C2, they're similar because this line parallel with BC. So then we can get the C1, C2 over BC. This one equals AC1 over AB. Okay, so you got the C1, C2 over BC equals AC1 over AB. So then you got the C1, C2 will equals BC, that's 3, times AC1. AC1, that's 16 over 5. Then AB, that's 5. So you got this one equals 48 over 25. Okay, so you got this. AC1, that's equals 12 over 5. Now continue from the C2, C3. C2, C3, that's in this similar triangle. Okay, now let's see. We can do, but then you need to find the trend. Let's see, we got a C1, that's 12 over 5. C1, C2 equals 48 over 25. Now let's see. We got this. Then we got this. Now we need to calculate this. So now let's see first. Can we find any pattern here? Okay. I think we continue to do this way, we can get this answer. Now let's see how the book solves this problem. Yeah, first they calculate C1. CC1, that's 12 over 5. Yeah, then we got the C1, C2, that's 48 over 25. So you write this one is 12 over 5 times 4 over 5. Then you find the next one, that's 12 over 5 times 4 over 5 squared. Okay? Yeah, we already did it here. We got it here. We got this too. So you need to do another one. Find this pattern. Then this one you can take the 12 over 5 out. So this one is geometric consequences. 4 over 5, then plus 4 over 5 square, then blah blah, do this. So then that's equals 1 over 1 minus 4 over 5. This is the sum of this geometric consequences, then times 12 over 5. So this gives you Now let's give you this one is 12 over 5 times 1 over 5, then times 5. So that's equals 12, right? So have you got it? See, we got this too. Now you need to do one more derive to get the C2, C3. That's equals this. Then you write down like this, then you find the pattern. You don't need to calculate the others. Then you write the sum will equals this. Then you take 12 over 5 out. The left, that's geometric sequences when the ratio equals 4 over 5. Then that sum equals first term divided by 1 minus that common ratio. So this one simplify, got a 5. 5 times 12 over 5. Then you got an answer that's equals 12. Okay. Now let's see. The answer is 12. Yeah, see here. The answer is 12. Okay. So do you have other questions?
No.
No? No, now we can go to chapter 7. Now, chapter 7 is hard. I can teach you that. Let's do this step by step. Okay. So first, do you understand what is the bisectors?
It intersects at a line's midpoint.
You know, the bisector, actually you have two kind of bisectors. One is called perpendicular bisector. Is this. That means a line separates a segment at two equal parts, and also this line perpendicular to this segment. So like this line K, it's perpendicular bisector segment AB to two equal parts, AM and BM, and K is perpendicular to AB. This one called perpendicular bisector. Another one bisector that's called angle bisector. That means you have a line separate this angle as two equal angles. This angle AOB separated by this line M as two equal parts. So this is called angle bisector. So bisectors, you have two kind of bisectors. One is called perpendicular bisector. That means a line separates a segment to equal parts, and also perpendicular that segment. Another called angle bisector. This line separates this angle as two equal parts. So now let's see this example. Can you read this 7.1?
The line M is perpendicular bisector is the perpendicular bisector of line segment AB. Use concurrent triangles to show that if C is on M, then CA equals CB.
This sign don't have the arrow here. That means this one it's a segment.
I said line segment.
Yeah, segment. You know, if you add the arrow here, that means this one is a line. That means this one extended both sides. So that's like this. Okay, so that means this one extended both sides. If you don't have the arrow, so that means this one is a segment. Segment, that means this fixed here. They did not extend it any side, to any direction. Okay, so this is a segment. Then they ask you use congruent triangles to show that if C is on M, on this line, then CA equals CB. They ask you prove CA. I need to change this one to segment. They ask you prove CA equals CB. They ask you use congruent triangles. Use congruent triangles to prove, to show that CA equals CB. Can you do that? Can you tell me how to show CA equals CB?
Because AB and CM are perpendicular, and AM and MB are the same length.
Yes. Then what else? So you say here, if you try to prove CA equals CB, they tell you use congruent triangles. So can you tell me in this plot, which two triangles are congruent?
What do you mean which two are congruent?
You know, you need to find the two triangles are congruent.
Okay, then ACM and MCV are.
Right. These two triangles, you try to prove they are congruent, right? Then how can you prove these two triangles are congruent? Which theorem you can use to prove these two triangles are congruent?
Let's see, the side one. Oh wait, no. The side angle side.
Side angle side. Why?
Because both of them have right angles, and AM and MB are the same, and both triangles have side MC, and they're the same too.
Yes, you're right. So you can use two theorems to prove this. If you know, because line M it's perpendicular by AB, right? So that means these two triangles are right triangles. So then you can use L, leg for right triangles. So because AM equals BM, because and line M perpendicular bisector AB, so AM equals BM, and also MC is shared. So combine these two, and also you need to add these two triangles are congruent. So that means angle AMC equals angle BMC. This one equals 90 degrees. Then you combine these three, you use LL. So that means this one's a leg, this one another leg. You got these two triangles are congruent. ACM congruent with triangle BCM. After you got this one to congruent, then AC and BC, their corresponding sides. Therefore, they're congruent. This is one way. Another way, if you can also use side SAS for general triangles to prove these two triangles are congruent. Because AM equals BM, then this angle equals this angle. This side is shared. So you combine these three together, then you use SAS. Then you got these two triangles are congruent. Then C equals BC. Okay, very good. Now let's see 7.2. Can you read this problem?
In this problem, we will show that if AC equals BC, then C is on the perpendicular bisector of line segment AB. Let C be a point such that AB equals BC, and let M be the midpoint of line segment AB. Draw a diagram. Draw a line segment CM and then use congruent triangles to prove that line segment CM is perpendicular to line segment AB. Why does this mean that C is on the perpendicular bisector of line segment AB?
Okay. Say they said in this problem, we'll show that AC equals BC, and C is on the perpendicular bisector of AB. Okay. Say still this plot. Okay. Let C be the point such that AC equals BC, and let M be the middle point of AB. Then draw a diagram. So that means you make this one connect with this one connect this. You make AC equals BC, and AM equals BM, because M is middle point of AB. Now B, draw CM. You connect CM and use congruent triangles to prove that CM perpendicular with AB. So now can you prove CM perpendicular AB? Say, why does this mean that C is on the perpendicular bisector of AB? So first, you need to prove CM perpendicular with AB. What do you know that AC equals BC and AM equals BM? So can you prove CM perpendicular with AB? And can you tell me how you prove this? You still need to use congruent triangles. Can you find that two triangles are congruent? Can you see triangle?
Wait, this one's using the problem 7.1's diagram.
This one is similar with that, but then here it's use a different approach. So in the 7.1, they tell you M is a perpendicular bisect of AB, right? Here they did not tell you that. Here they tell you you have a point C, then AC equals BC and AM equals BM. Now they ask you prove CM perpendicular with AB. The condition is changed. Here they did not tell you M is perpendicular with AB. They ask you prove that. The condition they give you is AC equals BC and AM equals BM. You know, in geometry, a lot of problem, you know, they from they give you that condition, they ask you prove that conclusion, right? But then they change that conclusion to condition. Then condition change to conclusion. They ask you, can you do that work, that direction? So now let's hear. Say in the first problem, they tell you M is bisector perpendicular with AB and also AM equals BM. In the previous problem, they give you this. Then they ask you prove AC equals BC. So we already proved that. Now they ask you go back from AC equals BC, and then they also give you AM equals BM. They ask you combine these two to prove like M perpendicular with AB. They ask you prove this. Okay? So then what do you know? It's AC equals BC, AM equals BM. So can you prove CM perpendicular with AB? Can you do that? You can consider these two triangles, ACM and BCM. In these two triangles, you have AC equals BC, AM equals BM, right? And also the shared side CM. Then which theorem you can use to prove these two triangles are congruent? Which one you can use to prove these two triangles are congruent? That's sides, 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 right? So we have three pair of sides are congruent. So then we can use SSS to prove these two triangles are congruent, right? After we get these two triangles congruent, then the corresponding angle will equal. So this angle should equal this angle because they are corresponding angles. They're corresponding to opposite of this side. These two angles should equal. Suppose this is angle 1, this is angle 2. So angle 1 need equals angle 2. But also angle 1 plus angle 2 equals what? Because AB it's a straight line. Then on this middle point M, they form this angle. This is a straight angle. So that means angle 1 plus angle 2 equals 180 degrees. Then you combine this, you can get angle 1 equals angle 2 equals 90 degrees. Right? Because say these two angles are equal. Then they add together, they equals 180 degrees. So that means each one equals 90 degrees. Each one is 90 degrees. Okay? So that means CM perpendicular with AB. So we proved that. Right? So then we proved this. Then now let's see. They ask you, why does this mean that C is on the perpendicular bisector of AB? Because CM is perpendicular and also bisector AB. Therefore, C is on the perpendicular bisector of AB on this line M. Okay? Do you have any question?
No.
Okay, if no, now let's go here. 7.3. Can you read this problem?
In this problem, we show that any point on the angle bisector of angle bisector of angle XYZ is equivalent from ray yx and ray yz. Yeah. Let C be on the angle bisector of angle XYZ. Draw angle XYZ and segments from C to the sides of angle XYZ that are perpendicular to ray Y. Is that a Z or an X?
This YX.
Ray YX and ray YZ respectively. Use congruent triangles to prove that the two segments from C to the sides of the angle are equal in length.
Okay, you can see this graph. See the angle as X, Y, Z. Okay, so this one tell you if that's a C, it's on the angle bisector of this angle X, Y, Z, then C will have the same distance to this side, angle side X, Y, and Y, Z. So if C is on the angle bisector, then from C, then you draw a perpendicular line to X, Y, you got a CP. Also from C, draw a perpendicular line to YZ, you got a CQ. Then you will have CP equals CQ. So here, how can you prove this? They tell you use congruent triangles to prove that, to prove CP equals CQ. So from this graph, connect which 2 points, then you can form 2 triangles. That 2 triangles, you can prove that they're congruent.
C and Y?
Yeah. Great. Connect CY. Then can you prove which 2 triangles are congruent?
CYQ and PCY.
Right. So which theorem you can use to prove these 2 triangles are congruent?
SAS.
SAS. Why? Why SAS?
Because both triangles share a side YC.
Yeah.
And PC and CQ are the same. Are the same because each have
No. PC is the, now let's see, okay, C is on the angle bisector. Draw this one that perpendicular to this. Then use congruent triangles to prove this to, here they ask you prove this. You cannot use this. Okay, this one is actually is graph of this one. The later than you suppose in the 7.4, you suppose you know this one equals this. Then they ask you prove these two angles are equal. So here in this problem 7.3, you only know this is C on angle bisector of this. So that means you have these two angles are congruent. So then they ask you prove CP equals CQ. Okay, what is theorem you can use to prove these two triangles are congruent? Say this angle equals this one because they tell you C is on the angle bisector of y, x, y, z, right? So we have this angle equals this angle. And this angle equals this angle equals 90 degrees, right? Then we have the side YZ is shared by these two triangles, right? So then we can use angle side AAS to prove these two triangles are congruent. You can also set these two pair of angles equal, so that means this angle also equals this angle. Then you can use angle side angle. You can use no, that's angle, yeah, angle side angle. Use this theorem to prove these two triangles are congruent. After you got these two triangles are congruent, then CP and CQ, their corresponding sides. Therefore, they're equal. So we proved. Okay? So now let's work on 7.4. Can you read 7.4?
See the point is inside angle XYZ such that C is distant from where YZ and where YX is shown. Show that C must be on the angle bisector of angle XYZ. And what does equidistant mean?
Huh?
What does equidistant mean?
What is, I did not hear, what, can you see again?
What does equidistant mean in the problem?
The question is, now here they switch the conclusion to the condition. You know, the previous problem, they give you C, it's on the angle bisector. Then they ask you prove CP equals CQ. In this problem, they give you CP equals CQ. Then they ask you prove C is on the angle bisector of this angle XYZ. So they, as what I told you, it's just to switch the condition and conclusion. So like this, the previous problem like use give you statement A, ask you prove statement B. Now this problem is like give you B, ask you prove A. Do you understand?
Say
not really. Yeah, for the previous problem, they give you the statement is C is on angle bisector. On angle bisector. Angle bisector of angle XYZ. Then they ask you prove CP equals CQ. Okay? They ask you prove this. Now they change this. They change that they give you CP equals CQ. They give you CP equals CQ. Then they ask you prove this. Prove C is on angle bisector of. They ask you prove this. They change the conclusion from the previous problem to the condition of this problem, the angle XYZ. Okay? So then, can you do that? Can you prove that? So, same thing. You need to connect which 2 points help you to get the 2 triangles. Then you prove that 2 triangles are congruent. Then, to get the 2 angles are equal. Then prove that C is on the angle bisector of angle XYZ. So you still need to connect YC. Connect this. Then you got these 2 triangles, YCP and YCQ. Now, what do you know? They give you CP equals CQ. Now you have this. This one equals this. Then you also have CY is shared. CY equals CY. Right? Now you also have CP perpendicular with XY. So that means this angle CPY equals CQY. That's equals 90 degrees. Then what theorem you can use to prove these 2 triangles are congruent? Now see what you have, that CP equals CQ. CY is shared. And this angle equals 90 degrees. So then you can use HL. This one's hypotenuse, this one's leg in the 2 right triangles. You got these 2 triangles are congruent. So you got a triangle YCP is congruent with triangle YCQ. Okay? You got these 2 triangles are congruent. Then after you got these 2 triangles congruent, then the corresponding angles are equal. So that means this angle equals this angle. Right? Because they are corresponding to this side, opposite of this side and this side. So then we can get angle CYQ. Therefore, you know C is on angle bisector of angle, right? So then we got conclusion. We proved this problem. Now, do you have any questions? Okay, if you don't have any question, exercise problem. Okay, here, can you read this number 1?
What is the perpendicular bisector of both one segment AB and one segment CD? Which of the following words be true and why or why not?
Is AB equals CD?
It cannot be true and it can be true sometimes.
So that means you if sometimes true, sometimes wrong, you just said no, right? You cannot guarantee. So here, that means if you said that true, that means guarantee. If M is perpendicular bisector AB and CD, will guarantee AB equals CD. So can you give me when they have equal, when they're not equal? Can you give me a example when they're equal, when they're not equal? You can see here, suppose this one is AB, this one is CD. Then I have line M, okay? Suppose this is line M. This one is A, B. This one is C, D. The M perpendicular and also bisector. Suppose this one is M, this one is N. Then AM equals MB, CN equals DN. But AB is not equal to CD, right? You can also change the length of segment CD, make CD equals AB, right? But you cannot guarantee AB equals CD. So that means this one, that's wrong. We cannot guarantee that. Okay? So then can you read B?
AB is parallel to CD.
Is this one guaranteed? Yes. Yes, that's true. Why? Because this one perpendicular with AB, also perpendicular with CD. So this angle and this angle, they're corresponding angles. They're all equals 90 degrees. Therefore, AB parallel with CD. Yes, that's right. And AC equals BD. They ask you this.
No.
Why?
Because from AB's midpoint to B, that part could be shorter.
Can you give me an example? You know, in this example, is AC equals BD?
What you drew is yes.
Yeah. Can you give me an example? The AC is not equals BD.
When B to the midpoint of the line segment AB is either shorter or longer.
Can you draw it? Can you give me an example? AC is not equals BD. Can you draw on my screen?
Like maybe when this is longer.
If you know that's longer, then the M is not perpendicular bisector of AB. You know, they give you the condition is M is perpendicular bisector of AB and CD. If you make this side longer, that means AM is not equals MB. So that means M is not perpendicular bisector of AB. you're against that condition. You cannot make that number. AM has to equals MB. And Cn has to equals Dn. Otherwise, M is not perpendicular bisector of AB and CD. So now, actually, this one's true. This one's correct. This is guaranteed. Why? Then you can draw a perpendicular line here. We can get the two congruent triangles. You draw a perpendicular line here, then you draw a perpendicular line here. So suppose they intersect with this one is E, this one is F. Then we can prove triangle ACE and BDF. These two right triangles are congruent. You know why? Because AB parallel with CD, so AE will equals BF. Because in the two parallel line, they have the same distance everywhere. So AE should equals BF. Then because CD minus AB, AB equals EF. So then also, CN minus this EN equals CE, right? FD, that's equals DN minus NF. So that means CE also equals DF. Then in these two right triangles, we use leg, to get these two right triangles are congruent. Therefore, their third hypotenuse also should be congruent. So that means this is true, guaranteed, they are equal. Do you have any questions?
No.
Okay. So now let's see number 2. Can you read number 2?
Scribble the points that are equidistant from the two intersecting lines. What does equidistant mean?
This means what is if these points have the same distance to their two intercept lines, what is this point should be followed? Where is this point? Where is the location for this point? Can you draw? You can draw, say this is one line and this is another line. Intersect these two lines. Suppose this one's K. Okay. Suppose this line is K. This line is L. They are intersect with, suppose that's O. Then they said a point has a distance, same distance. Suppose from this point, draw the perpendicular line to this side, also draw to this side. Suppose these two sides are equal, okay? This right angle. Now, this is the one point. Suppose this one's P1. Then the next point, suppose that's P2. Then you also draw the perpendicular line to here, then perpendicular line to here. Then they ask you all these points have the same distance to these two lines on the where is the location? What is the characteristics these points have? These points have. This is exactly the angle bisector. All these points should be on the angle bisector. Otherwise, they cannot have the same distance to these two sides. All these points, if you connect O with P1, P2, this OP1, OP2 bisect these angles, bisect this angle. So that means all these points should be on the angle bisector formed by these two intersecting lines. Okay? Yeah, that's exactly they ask you. Now we can check how the book tells. Now let's check this. Say, 2, can you read this?
Which one?
Read this solution.
2 intersecting lines from 4 angles measure between 0 degrees and 100 degrees. Set of all points equidistant between these two lines are the angle bisectors of 4 angles. That is formula bisectors from 2 lines Can you prove this?
See, they tell you this point should be on the angle bisector, right? That's exactly I told you. Then they also ask you, can you prove that? If you try to prove this, very easy. You just use these two congruent triangles. Suppose this one's A, this one's B. Now this point is P1, right? So in the triangle OAP1 and OBP1, these two triangles, they have OP1 is shared. This side is shared, right? And P1A and P1B, they're equal. And we also know there are two right triangles. So then we use HL to prove these two triangles are congruent. Therefore, this angle will equal this angle. So we proved, right? So then this problem tells you if the points have the same equal distance to the two sides of intersecting lines, they should on the angle bisector. Okay. Now let's see number 3. Can you read this number 3?
Describe all the points that are equidistant from 2 parallel lines.
Okay, similar with previous problem. Ask you, what is this point? Can have the same distance to the two parallel lines. The previous problem, if these points have the same distance to the two intersect.
Is it like this? Wait, never mind. That's not a good line. Like one. One like in the middle.
Yeah.
Of these two lines.
Exactly. Yes. All the points should be on the middle line of these two parallel lines. Otherwise, how they can have the same distance to these two parallel lines? They should on the middle of these two parallel lines. Okay. So time's up. We can stop here. Your homework. Then you continue work on this. I feel you're not familiar the congruity of triangles. You need to review that part. That's the basic skills. You need to familiar that part. Otherwise, then you have the difficult to prove the other problems. Okay. Yeah. You need to familiar. That's what is how you can get these two triangles and how can prove that two triangles are congruent. Okay. So then you continue work on the